So I'm back today to give you a quick tutorial just on the characteristics of sediments that influence porosity and permeability. So hopefully you've gotten to that point in your unit of surface processes, but just as a quick recap, porosity is just the space between sediments. It can be big, it can be small. Permeability is the ability for water to go down into the ground through those pore spaces. Eventually it'll become part of the water table and the zone of saturation. Couple characteristics here. First off is packing. So sometimes sediments can be loosely packed. Loosely packed just means that they're really far away from each other. The farther away they are from each other, the bigger the space for the water to infiltrate into. Infiltration and permeability, they kind of deal with the same idea of water going into the ground through the spaces. Water likes big space. So when sediments are really far apart, it's easy for water to get through. When sediments are really close together, now those pore spaces are a little bit smaller, much harder for the water to get through. That's characteristic number one. Characteristic number two is shape. So you have rounded sediments. Rounded sediments don't really have a lot of contact. There's not a whole lot of contact with a rounded sediment. So what happens here is that these rounded sediments, when they get packed together, they're still somewhat loosely packed because you end up getting these big spaces. Even when they're touching each other, you have these massive spaces for the water to infiltrate down. High permeability. You have a high porosity here. The sediment on the right, this sediment over here, has flat sides, angled sides. They get really close together. Much harder for water to get through because the spaces are so small. So you get a sediment that's tightly packed with angled sides, that is a really poorly drained soil. Even with a tightly packed soil sample that's rounded, you're still going to get some pretty decent sediments. The third characteristic is the fact that your sample wants to be uniform in size and shape. So you want about the same size and shape sample. Okay, in both cases, they're about the same size and shape. The problem occurs when you mix them. Because what happens here is that these sediments that are really small, they clog up the spaces in between the bigger sediments. So what happens is, even though you got some big spaces, those little guys, if it's not uniform, remember the word uniform means the same. Your favorite sports team, everyone wears the same uniform. Giants, Mets, Yankees, Jets, that kind of thing. They all wear the same uniform. So what happens is that just allows you to make everyone looks the same. You want all your sediment to look the same. If it's not the same, that's going to influence porosity and permeability. Whenever you have a mixture, that is the lowest porosity and the lowest permeability whatsoever. So the best drained soil that you can get is going to be soil that is going to be rounded, loosely packed, and uniform in size and shape. So in this case, if this was a gravelly or pebbly soil, this would be a really good soil sample because your sample is uniform. It's all the same size and shape roughly. It have some big spaces kind of loosely packed here. And then that's going to allow water to drain through really easily. It's well sorted here. Okay, these angled fragments over on the side, not so good. So hopefully that kind of gets you in the right track in terms of the characteristics of your sediment. Make sure you take a look out for some new videos that are going to be posted regarding porosity, permeability of your soil samples. So hopefully some of those demos will help you out down the road. Until next time, everybody, talk to you soon.